Good morning, class. We are looking at Chapter 1, Sequences, Section 1.6, Sequences and Difference Equations. And we're going to look at one more example of that. Example number 6, Pacific salmon populations have discrete breeding cycle in which they return from the ocean to streams to reproduce and then die. This occurs every 1 to 5 years, depending on the species. Suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with a probability of D. After swimming upstream, each fish produces B offsprings before dying. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. What is the discrete time recursion for the population dynamics? Assuming that there is no mortality while at sea, you should count the population immediately before the upstream journey. Part B, suppose that instead of preying on fish while they swim upstream, bears do so while the fish are swimming downstream. What is the discrete time recursion for the population dynamics? Again, we are assuming that there is no mortality while at sea. And finally, we want to compare and contrast which of the recursions obtained in part A or B predicts the largest increase in population size from 1 year to the next. Justify your answer both mathematically and in terms of underlying biology, where D is between 0 and 1, B is larger than 0. I'm going to discuss that later on for you. All right, so the first part. Suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with the probability of D. Number one, how many fish do we have? X, Y, Z, N, and I'm going to call it N sub T. That means N at time T. You can pick any variable you want. Now, some of them will be taken by bears. It's a percentage. D represents a percentage that will be gone. For example, if D represents 10%, then 90% remains. So we are going to call this now N sub P, which is N sub T minus D times N sub T, or simply this number times 1 minus D. Again, I want to make sure Y 1 minus D. That's the complementary event. So if 20% is gone, 80% remains. That's what happens. Then each one goes up, okay, produces B offsprings before dying. So simply put, just multiply this one by B. So N sub P plus B times N sub P and minus N sub P. They cancel each other because they all die. So simply put, this one times B, and then we add M additional newly hatched fish. So let's add M. So that's the number we get for part A. In part B, suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming upstream. So in other words, we have N sub T, all of them get up there, and they give us B offsprings before dying, so B times N sub T. So that's what we get. Then we add M. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. So add M. Now at the end, all fish face predation with probability of D. That means, again, if D is 10%, 90% remains. So 1 minus D times that, and that's the number we get in part B, 1 minus D times B and T plus it. Now, finally, compare and contrast. Which of the recursions will give us more? And you can assume D is between 0 and 1. B is, of course, positive. Now, B is the number of offsprings is positive. They are larger than 0. I want to explain the probability. The probability is between 0 and 1. Can it be 0? Yes. So we can have the equality. Can it be 1? Yes. But it's never negative. It's never larger than 1 or 100%, okay? That's important to know. So when we say we're going to give it 110%, it's mathematically wrong. Okay, just emphasize that we put Allah. So which number is larger? Well, mathematically it's simple. Just say A minus B and work it out. It's positive, A is larger. It's negative, B is larger. Or B minus A, positive, B is larger, negative, A is larger. So part A minus part B. It's very simple math. So this is B times 1 times n sub t minus B times d n sub t plus m. And this one, you just do the foiling, 1 times B and t, m minus B d and t minus dm or md. So you just do the elementary algebra and do the math. Now we're going to distribute, and this doesn't change this one. Each piece takes an opposite side, minus B and T minus M plus BD and T plus MD, and these two cancel each other. These two cancel each other. These two cancel each other. We end up with MD, remember, D is positive, and M is the number that we add. Both of them are positive. The product is positive. If A minus B is positive, that means A is larger. So how does it make sense? Well, part A, all the additional fish, remember, M is the additional fish, the ones that we added. All of them survive. But in part B, all fish, including those that we added, have to face predation. That's why.